Okay, for part 9e, we're differentiating using the quotient rule, and the quotient rule, we use it when I have something that looks like this, where I can split it into two separate functions. So if you look at this example, I've got y is equal to x over 2x plus 5. This can be my u, and this is v. And then to differentiate that, I have to put v times the derivative of u, take away u times the derivative of v over v squared, and it has to be in that order. So this is always at the bottom, v squared, and you always begin with that, and never forget this negative. Okay, let's put this into practice. I've got y is equal to x over 2x plus 5. So this is u and this is v. And now I want to differentiate both of them. So u dash is equal to 1, v dash is equal to 2. Now applying the formula, dy by dx is equal to, at the bottom I have v squared, so this is v. And then I have to begin with v, so that's 2x plus 5 times by u dash, which is just 1. Take away u times v dash, so that's going to be 2x. I tidy this up, these two cancel out, I'm left with 5 over 2x plus 5 all to the power 2. We'll look at another example. I've got find the stationary point of y is equal to sine x over e to the power 2x. To find the stationary point, I need to first differentiate. I need to find dy by dx and then make that equal to 0. So here I've got, this is v and this is u. So I'll write that down. U is equal to sine x and v is equal to e to the power 2x. Now I want to differentiate both. U dash is equal to cos x and v dash is equal to 2e2x. Now applying the formula, dy by dx is equal to v squared, so that's squared, e to the power 2x to the power 2, and then I begin with v and then I multiply by this, so that's e2x times cos x, take away this 2e2x times sine x. I can tidy this up. I notice I've got e2x in all three terms, so I can cancel that out. One from here, and one from here. I'm left with cos x minus 2 sine x over e2x. Now the second part of the question, I've differentiated. Now I want to make it equal to 0 to find the turning point. That will give me cos x minus 2 sine x over e2x is equal to 0. I multiply both sides by e to the power 2x. That leaves me with cos x minus 2 sine x is equal to 0. I'll bring the sign over. Cos x is equal to 2 sine x. I'll divide by 2 and divide by cos. 1 over 2 is equal to sine over cos is tan x. And then we want to put that in calculator. Make sure your calculator's in radian. So shift tan of 0.5 is equal to 0.464. So x is equal to 0.464. Our interval is between 0, so x is between, the second part of the question that I forgot to write, which is very important. X is between 0 and pi. So I don't need to add pi to this because tan repeats every pi, but because I need it to be between 0 and pi, that is your final answer. I want to find the turning point or the gradient at this point. So I'm going to substitute that back into the original equation. That will give me y is equal to sine 0.464 over e2 to the power x, and x is 0.464. That will give me, so sine 0.464 divided by 2 times 0.464, 0.177 And because they want a point, they said stationary point, I'd write that as, this is my x value and y value, so 0.464 and 0.177. That would be your answer for that question. Last example. We have this, differentiate with respect to x, giving your answer in its simplest form. This is the function that we have. So dy by dx will be, this is v and this is u. So v or u is equal to sine 4x, and v is equal to cos x cubed, u dash is equal to 4 cos 4x, and v dash is equal to 3x squared. So dy by dx is going to be this squared, so that's going to be x to the power 3 all to the power 2, and then I begin with v, x cubed times u dash, take away u times v dash, and then I notice I can cancel out x. I've got x to the power 3, x to the power 2, and x to the power 6. I can take away x to the power 2 and all 3. That leaves me with 4x cos 4x minus 3 sine 4x over x to the power 4.